Hi Thomas, this is Arezi. This is my quiz 3 problem 2. I am in the airport, so please forgive the sound. If it's really bad, I can resend you another video. So for quiz 3 problem 2, the student needed to know vector addition, the properties of momentum, and how momentum relates to net force. Before I began the problem, I started to think about what I needed to know based on what the problem was asking me for. So the first thing I thought about is momentum, P, is equal to mass times velocity. And then I thought about what that actually meant in relation to the problem. So the problem states that point A and E, at point A and E, the ball has zero velocity momentarily. So at those points, I knew that momentum is zero because the velocity is zero. Then I thought about what is dp dt, and dp dt is net force. So parallel force would be in the x direction and perpendicular force in the y direction. So using that information, I got the following answers for dp dt in the parallel direction. At point A, it's 9, point B is 3, point C is 3, point D is 3, point E is 9. The perpendicular direction, point A is 9, point B is 5, point C is 1, point D is 5, and point E is 9. And finally, the net force at point A is 9, at point B is 4, at point C is 3, at point D is 2, and at point E is 9. The way that I figured this out is by doing vector addition and then also decomposition of vectors. So for example, I have the ball at point B. At point B, there's a tension in the spring in this direction, and then there's the force of gravity. So then what I did is I took that tension in the spring, added the force of gravity to it, and got that a resultant vector pointing in this direction, which is direction 4. From there, that led me to the fact that the force at point B was 4. To get dp dt parallel and perpendicular, I decompose the vector. Since the vector is pointing downward and to the right, it would mean that in the horizontal component, it would be pointing rightward, and the vertical component would be pointing downward, which led me to directions 3 and 5. So that is essentially how I went about solving problem 3. I apologize for the quality of the video because I am in the airport, but again, if I need to send another one, I will. Thank you.